All right, hello students. Today I'm going to be going over the Unit 5 test review. Hopefully you guys are going to be doing this when you have Mr. Martinez as your sub. But anyways, let's just get started. So this first line, it says, if highlighted problems are done, then one assignment is going to be dropped. So let me highlight those problems. It's going to be this one, this first one. It's going to be this fourth one in the bottom right. And then I wanted to do the first one. I wanted to do the third one. I wanted to do this one and this one. And then I wanted to do the first and last one. And then for here, I wanted to do one of each. So I'll just do this one, and then I'll do this one, and then the last one. And then we're going to set up both of these. But mainly, the most important one is the second one. And then the last one's going to be this one. So we're going to be doing a lot of them, so it might just be to your benefit to do the rest of the problems so that you can get 3 assignments dropped in case you're missing any assignments. Let's say you're not missing assignments. I think it'll still help for you to just practice on your test, or maybe if you want some extra credit. But okay, we're just going to get started. Let me not take up too much of your time. Okay, so part 1, lesson 5.1, 5.2, 5.3, it had to do just with factoring and solving quadratic equations. Meaning we need to have our equation in standard form, and then we need to factor it by either using grouping or the box method. I'm going to be doing one of each, but I prefer grouping because it's very easy to see the math that's being done. But let's just start with box method real quick. So here's the function. But the thing with this function is that it's not in standard form. So the way that we get this function in standard form is by having all the terms on one side, which means we got to add that 10 to both sides. If we add that 10, then this 10 cancels out, giving us x squared plus 7x plus 10 equals 0. And now that it's in this form, we could draw our box pretty easily. We'll make a tree just already. And we're going to put in the x squared, which is just the first term, whatever's here. And then the 10, which is just whatever's in the back here. So now our goal is to find two numbers that are going to multiply to 10, which is going to be the last term right here, and add up to the middle term, which is 7, right here. I mean, it has to multiply to 10 and add up to 7. So if you're not sure, you could just list out all of the factors. But in this case, 10 only has 2 pairs, 1 and 10 and 2 and 5. It's very easy to see that these are the ones that add up to 7 and multiply to 10. So when we do that, we want to write them in here. We fill them into the box. And don't forget to put the little x next to it, right here. But from this point, we want to find the greatest common factor for each column and row. So let's say we're going to work with this column. The question we ask ourselves is, what do they have in common? I see they both have an x, so maybe we're going to factor out an x. We could divide both of them by an x. Now we move on to the next column. What do they both have in common? Well, we can't divide both of them by x because this one only is a 10. It doesn't have the x. We could divide them both by 2, which looks good. Yeah, 2x divides by 2 and 10 divides by 2. So we're always looking for the greatest common factor. We're looking for the biggest number, the biggest, let's say, term to divide by. So now we look at the rows. So x squared and 2x, they both got an x. In the second row, they both divide by 5. So very easy. Now we got it like that. We could just group this term and this term like this. So we end up with x plus 2, x plus 5. Remember that it's equal to 0. From this point, we could just equal each one of these individually to 0 so that we could find our x value. So for example, this first one, x plus 2 equals 0. That means we have to subtract this 2 on both sides, which means that x had to have been negative 2. That's one of our answers. And a little shortcut, if it's convenient, if there's no coefficient by x, we could just flip the sign of whatever's being added. So for this one, it's x plus 5. Means our answer is x equals -5. There is our answer. So I feel like doing the box method is pretty orderly, pretty intuitive if you've had enough practice. But let's see how the grouping works. So we got a similar issue where all of the terms are not on the same side. So a quick fix we could do to that is add 7 to both sides. That's going to give us -4x squared plus 3x plus 7. That is equal to 0 because this canceled out right there. So now for grouping, it starts off the same way. We want to find whatever two numbers, multiply to -28 and add up to 3. And now you guys might be thinking at this moment, well, where the heck did the -28 come from? Well, that's because we always have to multiply the number in the front by the number in the back. And in this case, it gives us -28. And our sum is still going to be 3. So I'm just going to put S for sum 3. It's still just going to be that term in the middle. If you noticed in the previous question, it was the same thing. We multiply the number in the front by the number in the back. But in this case, the number in the front was just 1. So it's 1 times 10, which is just 10. But anyways, we got these two numbers. Okay, so two numbers to multiply to -28, but add up to 3. Well, maybe 1 and 28, 4 and 7. Well, one of the numbers needs to be negative because our product is -28. And since the sum is positive, it's just -4, +7. So these are our two terms. And now that we got our two terms, we want to rewrite our equation as such. We have this middle term, 3x, and instead of 3x, we're going to rewrite it as the sum of both of our terms. So we got the -4x and then the +7x. Still with that x like in the box. And then we have +7 equals 0. So if you really think about it, we're just rewriting this as 3x. So -4x plus 7x, that equals 3x, which is up here. It's just a way of rewriting it so that we can manipulate it algebraically. And the reason that this is called grouping is because we can group each of these pairs of numbers. We group them. So with this first group right here, let me underline it again. Right here, this first group, that means we want to look at these two terms and take out the biggest common factor. So I see we could divide both of them by a -4, and they both have an x. So we could divide each of that. We could factor that out of both of those terms. And when we do that, we're left with a +x and a +1. When we divide a -4x by a -4x, let me underline exactly what's going on. I'm dividing this -4x by this -4. Well, we end up with 1. We move on to the next group. 7x plus 7. That's just like divide. Okay, so we could factor out a 7. And that is just x plus 1. And you'll know you did everything right if that little parentheses is equal. The terms in that parentheses, they're equal. So once we do that, we could factor that out again. And whatever numbers are left, in this case it's -4x and +7, those are going to be our terms, or our terms for the second factor. Equals 0. So we got it in a very similar form as we did the last question, just two binomials. So same process. We want to equal each term to 0 and solve for x. So here I'm doing the first one. -1 minus 1, x equals -1. Very simple. We could have just flipped it. But for this one, it's different. The second one. That's -4x plus 7 equals 0. Well, we have to subtract the 7. Meaning we're left with -4x equals -7. And if we divide the -4 off of both sides, we're left with an x equals +7/4. Because the negatives cancel out. So it's just a simple algebra expression that we need to solve for x. And that's going to be the case pretty repeatedly. So just keeping in mind, this is just one way to solve for quadratic functions. And when we're solving, we're finding x values. Okay, so we're done with that. Now let's move on to part 2, which is simplifying radicals. And the way that we're going to do it is we're going to divide by the biggest perfect square. And if you guys forget what your perfect squares are, just write it up here. 1, 4, 9, 16, 25, 36, 49, ... And if you don't know where these numbers come from, this is just going to be 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, ... So that's where they come from. And we're trying to find the biggest perfect square that divides into our little radicand, which is the number in here. So I look at 75. I'm like, okay, what's the biggest number I could divide by? The first number I think of is 25. You could rewrite, whoops. You could rewrite 75 as 25 times 3. And you might be wondering, what's the significance? What's the point? I get that 25 times 3 is 75, but why do we care if we could write it like that? Well, the point is, if you recall the product property for radicals, that means you can split up a radical like this. Radical 25 times 3. And now, this is a basic question now. What is the square root of 25? Well, that is just going to be 5. And the square root of 3, we don't know what that is. So that is how we simplify radicals. Pretty simple. Not too crazy or anything. And now, let's move on to this next one over here. So 3 times square root 32. So what I'm going to do is I'm just going to write that 3 because it's on the outside. Now what I'm going to ask myself is 32. Okay, that's my radicand. That's the number I have in the inside. What's the biggest number I could divide by that is a perfect square? So I could divide by 4. I could also divide by 16. So 16 divides into 32 2 times. Like that. So I got that. And we're just going to recall our product rules. So that means we could separate it like this. And now, when we look at something like this, this is just 3 times the square root of 16 times 2. Let me do a little multiplication symbol there. But we know what the square root of 16 is. So in reality, this is just 3 times 4 times the square root of 2. And we also know what 3 times 4 is, obviously. We know 12 times square root of 2 is an equivalent expression of 3 times radical 32. So we're just simplifying. It's just, let's say, common algebra skills that we need to get good on so that we can manipulate more things in the future. So let's look at these next two. Negative 45. Okay, so now I'm thinking, what's the biggest perfect square? Negative 45. Well, I got 9. I think 9 divides into 45. But one of the key differences that you'll see is that there's a negative 1 right there. So whenever you see a negative, you can think about replacing it like this. Negative 1 right there. And then, well, we said 9. And then and obviously 5 is left over if we divide 45 by 9. So we have all these things, meaning the product property, we can take it out individually. Radical negative 1 times radical 9 times radical 5. So from here, we just take it a step at a time. We got this radical 9. We know that that's just 3. And let's also recall some extra knowledge. We know that anything that's square root negative 1, that's going to be I. Anything, well, and anything that's left over is just going to be left over. So once we finish, this is our answer. 3i square root 5. Might look a little weird, but the main rule to think of is that any negative inside a radical, you could immediately take it out as I. So for example, let's look at this next one. We got square root negative 8. So we see that negative in there. That means we could just take out an I like this. So That just leaves us with a positive 8 inside and the I on the outside. So now that we're dealing with this, we could deal with it the same way we've been dealing it. What is the biggest perfect square that divides into 8? So you just look up here. Well, 9 doesn't divide. Well, 4 divides. We could just do 4. 4 times 2. This means I times square root 4 times square root 2, which just means square root 4 is 2. So we got 2i square root 2. Easy peasy. So the reason that this is important is because sometimes we're going to need to simplify some radicals when we're solving for quadratic formulas. So I'm going to be expecting you guys to fill this thing out with me real quick. And what we're first going to go over is the quadratic formula. We got x equals negative b plus or minus the square root of b squared minus 4c all over 2a. And it's a humongous formula that it's easy to forget, 1 or 2 variables. But this is going to be provided to you. So just try to be at least familiar with it if you don't already have it memorized. But when we're looking at a specific part of the quadratic formula, which we call the discriminant, it tells us 3 different pieces of information based on the value of it. So let's say we put in all of these numbers and we get a number that's bigger than 0. That means we're going to have 2 real solutions. If we get a value that's equal to 0, that means we're going to have 1 real, and in parentheses I'm going to use the word double solution. And if it's less than 0, it's going to be 2 complex solutions. So 0 real solutions, but 2 complex solutions. And lastly, we got some extra information. If the discriminant is a perfect square, which we already discussed, that's like 1, 4, 9, 16, 25, 36, 49, etc., then the solution is rational, meaning it's just going to be a simple number that we could write as either a whole number or a fraction or an integer or whatever. If it's not a perfect square, if it's not one of these 1, 4, 9, 16, 25, then our solution is going to be irrational, which means it's typically expressed with a radical. We're going to see if we have any examples like that, but let's just work with that with these first 2. So it's saying solve the quadratic equations using quadratic formula, state the number and type of solutions. So it's going to help us to find the discriminant so that we can get some information on the types of solutions. But before we do that, we have to make sure that our equation is in standard form, meaning all the terms on one side. I see that 5 over there is just hanging out by himself, so let me just move that over here. So once I do that, we get left with 2x squared minus 3x minus 20. All of that equals 0, because 5's cancel out. Now here, let's just write down our A, our B, and our C. Our A is going to be 2, which is this number in the front. Our B is negative 3, which is the second number, and our C is negative 20, which is this third number. And this is assuming that all the terms are on the same side. And now when we're doing this, we need to find the discriminant. So let's recall this equation. B squared minus 4AC in the top right. So thinking about that, we got B squared, which is negative 3 squared, minus 4, then A is 2, times C, which is negative 20. This means we got negative 3 squared, which is 9. Negative 3 times negative 3 is a positive 9. Then we have minus. Then we have 4 times 2, which is 8, times negative 20. Now let's think about this. We got 9 minus 8 times negative 20. So that's like plus, let's see, 160. 8 times 20 is 160. Since they're both negative, it turns positive. So that means this is 169. 169 is a positive. It's a positive number. It's bigger than 0. I circled it at the top right. So since it's bigger than 0, that means we're going to have 2 real solutions. So discriminant is 169. Number of solutions, 2. We're going to have real type of solutions. And also, 169 is a perfect square. It's rational. We're going to see exactly how it's rational. So now let's just plug in these numbers. X equals negative b, which is negative 3, plus or minus the square root of the discriminant, which is 169. All of this divided by 2 times a, which is 2. So this is basic arithmetic. Negative 3, that's positive 3. Plus or minus the square root of 169. Well, no, that's just 13. 169's square root is 13 times 2 times 2. So now that I have this simple expression, we just write it as two answers. One that's with the plus, the other one that's with the minus. So we can do some mental math real quick. 3 plus 13 is 16. 16 divided by 4 is just 4. Next one. 3 minus 13 is negative 10. Negative 10 divided by 4, well, we could just keep it like that. We could also rewrite this as negative 5 over 2, but they both are perfectly fine. So it's pretty simple. It's just a matter of using the equation and using these facts in the top right. The discriminant value dictates the types of solutions that we'll have for our equation. So now that we got this one, or now that we figured out that one, let's check out this bottom right one. So x squared minus 6x plus 22. Let's make sure it's in standard form. That means x squared minus 6x stays the same. And that 22 gets subtracted by 10, meaning we're going to have a 12. So, okay, we got that. And it's also equal to 0 because the 10's canceled out. We got a is equal to 1, b is equal to negative 6, c is equal to 12. And we're going to do the discriminant equation. So negative b, or rather b squared, which is negative 6 squared, minus 4 times a, which is 1, and then times c, which is 12. So let's see what we've got. Negative 6 squared, that is 36. Minus 4 times 1 times 12, well, that is just minus 48. And this is minus 12. Okay, so we got a negative number for a discriminant. Since it's negative, what does that tell us? Let's see. Oh, it's negative. That means we got two complex solutions. Okay, so number of solutions, 2. We got complex or imaginary. That's another way of saying it. And, well, we're going to have irrational solutions since 12 is not a perfect square. 12 is not a part of the perfect square numbers that we showed right here. But anyways, let's continue. X equals negative b, which is a negative 6, plus or minus the square root of our discriminant, which is negative 12. All of this divided by 2 times a, which is 1. Basic arithmetic. Negative 6, it's a positive 6. Plus or minus, well, now we got a weird expression in there. So this square root negative 12 looks very familiar to these questions that we were doing up here. And we're going to do the same exact process to simplify. So I know that we could replace negative 12 by negative 1 times, well, the biggest square that divides into 12 is 1, 4, 9. Well, it's just 4. And then the thing that's left over is 3. It's divided by 2. And now that we have this, we know that we could separate it all by writing each of the radicals separately. And when we do that, we could evaluate each one of them in a neat manner. 2. So I'm going to do a little line here just to show the math more clearly. And now we can just go one by one. 6 plus or minus. Square root negative 1 is just I. Square root of 4 is just 2. So we got 2i. Then square root 3. All of that divided by 2. And since I'm feeling a bit lazy, I'm just going to box in my answer like this. 3 plus I square root 3. That is going to be my answer. 3 plus or minus. And that happened because it's 2 divided into each of these. So you can check the math if I went too fast, but it all works out. It's just about using the equation and knowing how to simplify. So we just got a few more questions left. I know it's taking long, but we can do it. Got some complex number operations. So we're going to do 3 examples. This first one is just combining like terms. We got complex numbers. Let me erase this thing. Complex numbers are just a way for us to manipulate like imaginary numbers, and all we have to do is just treat it like a variable. So -2 minus 2i, then minus, that minus on the outside means that it's going to distribute everything on the inside. So that we got a +4 plus 3i, negative times a negative. And then that plus right here means it's just everything plus. And from here, it's pretty simple. We just combine all the like terms. So -2 plus 4 plus 7. That is just 2 plus 7, which is 9. And then we get -2i plus 3i plus 8i. That is just I plus 8i, which is just 9i, positive 9i. Pretty simple. Here it's very similar, but we just have to, it's similar in the way that we treat it as a variable, but we're going to have to FOIL. So foiling, we take that first number and multiply it by the first number in the second layer, which is 2 times 18, which is 36. Then we multiply that, which we got 18i. Multiply this inner one, which is -6i times 18, which should be -108 times I. And then -6i times 9i is going to be a -54i. And since there's 2 i's, it's squared. So the steps are the same. We combine what we can. This combines, meaning we got 36 minus 90i. And then this term right here, since it's got an I squared, we have to flip the sign of whatever it is. So since it was -54, but now we got a +54. And we just remove the I squared. From here, we just combine the last 2 like terms, which is just going to be 90 minus 90i. There's our answer. So now we look at this one. 10 minus 5i divided by 5 plus 3i. How are we going to possibly manipulate this? And the way that we're going to do it is by multiplying by something that's called a complex conjugate. So I'm going to write that up here just so you see the word. A complex conjugate is something that looks very similar to the complex number, but that sign in the middle is going to be flipped. So before it was positive, now it's going to be minus. So the complex conjugate of 5 plus 3i is 5 minus 3i. Emphasis on the minus. So the way that we start these types of questions is we multiply the equation by 5 minus 3i. Because whatever we do to one thing, we have to do to the other. In this case, whatever we do to the bottom, we have to do to the top. So once we do this, we're just going to FOIL. Same thing as foiling. So I see this and I see, okay, 10 times the 5 inside, which is 50. Then 10 times the -3i, which is minus 30i. Then minus 5i times 5 is minus 25i. And the last 2 numbers are plus 15i squared. Sorry if I wrote a little small. You could use your space a bit better. For the bottom one, we got 5 times this 5, which is 25. Then minus 15i. Then plus 15i. And minus 9i squared. And if you're confused as to how I'm doing it, you could just take each step very slowly, multiply each layer out like this, and then like this. Same thing for the top one. Just multiply each layer individually. That's all I'm doing. It's foiling. So the important thing you should realize is that this canceled out with this. The minus 15i plus the 15i, they just cancel out with each other. So we got a nice and neat expression of 50 minus 55i plus 15i squared. I took the liberty of combining these two things. All of that is divided by 25 minus 9i squared. And what did we say before? We see an I squared. That means we just flip the sign. So we got 50 minus 55i minus 15. All of that is divided by 25 plus 9. So we continue simplifying. We combine this with this. They're just numbers now because it's the I squared. We got rid of it. Meaning we got 35, which is 50 minus 15, minus 55i. All of that is divided by 34. And even more, we could just write our answer as 35 divided by 34 minus 55 over 34i. So this one looks like it took a lot more work, but it really is just the same thing. We FOIL, and then we just simplify the way we did in the other examples, making sure we use the complex conjugate. All right, just a few more questions. We're done with complex number operations. Let's move on to systems of equations. So systems of equations, it's extremely similar to solving any quadratic function. We just have to set it up in a certain way so that we understand it better. And these two questions, I'm going to set them up, and you guys, I'll leave it to you guys to solve it. So this is one equation. It's a quadratic, and this is a linear function, meaning they might intersect at some point that could look like this. If this is the quadratic function up there, then we could have another function. Whoops, that's a bad drawing. We could have a function that intersects them like this. And what we're interested is in those 2 points. Those points are going to have our x values, or our x and y values. And the way that we find it is we get both equations, negative 2x squared plus 4x plus 5, and we equal them to each other. And now that they're equal to each other, we could just manipulate it algebraically so that we can make it look like an equation that we know how to deal with. So all I'm doing is I'm adding 2x, or I'm subtracting the 2x to the other side, which cancels out. And I'm adding the 7 to the other side, which cancels out both on the right side, giving me negative 2x squared plus 2x plus 12. All of that equals 0. And I got this thing now, which is something that I understand very easily. That's just A equals negative 2, B equals 2, and C equals 12. You could also maybe factor out a negative 2 if you want. Maybe you could also just factor it normally. If you have a graphing calculator, you could also do that, like that one time we mentioned. But I would probably just use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I plug in those values into this equation and just do the simple math. It's very simple, basic arithmetic that isn't really algebra focused. So that's the process of setting up a system of equations. And now let's see how this one looks like. All right, so this one looks a lot weirder because that second equation is written all weird. So this first one looks completely fine, but the second one looks weird. So what we have to do is we have to make sure that we have the y by itself. At the moment, we have the y, but we also have that minus 2x on that one side. So we just have to make sure we add it to both sides. So once we do that, we end up with y equals 2x minus 4. And now we have this very neat equation that we could work with. Just remember, it's the same thing. If we want to know where they intersect, we have to equal them to each other. Equals 2x minus 4. From here, very similar process. Subtract 2x and then add the 4. Subtract the 2x and add the 4. Cancels out. X squared minus 8x plus 7 equals 0. And again, we have a very simple equation that we could just use solving quadratic formula or just by factoring, which you could probably get the factors very easily. Okay, so those are the main questions. And now you're going to have a few specific application questions that are going to challenge you by understanding what goes on with a quadratic equation, especially when we graph it. So we're going to do the bottom right one. So Alan launched Puneeth upward from the top of a 112-foot high cliff, and it was overlooking the ocean at a speed of 96 feet per second. Puneeth's height above the ocean can be modeled by the equation, and then there's the equation. So the main thing that we want to focus on is this negative 16 t squared plus 96t plus 112. So what we could do is we could just graph it. So you'll have Desmos on the test. Just negative 16x squared. I think it was plus or minus 96. It's plus 96. Then plus 112. Oops. So there's our function. And it might look a little weird because it's a little zoomed out. But if you just adjust it, then here we have a nice, easy to view graph. So, okay, they threw each other. Alan is very strong. Now the question is, when does he reach the maximum height? So the maximum height could be very easily viewed from where it's the maximum, up there. Which means he reached it at 3 seconds. At 3,256 means he got up there at 3 seconds. And the maximum height of Puneeth, we already saw, was 256 feet. Now the question is, when does he hit the ocean? When does he hit the sea level? Which should be modeled by this first x-intercept down here, which is just after 7 seconds exactly. So in my opinion, these are very easy questions to understand. You just kind of see the path. You could have some intuition about what goes on with the quadratic equation. And the other one is very similar to this second question. But anyways, that's all I have for the review. If you're worried about all these steps, if you're not sure exactly how to do each one of these questions because there's a lot of steps to remember, there's a lot of rules or a lot of thinking and a lot of hard work, just know that for the majority of these questions, you're going to be able to graph them on the Desmos calculator if you have it on the computer. The computer part of the test will have the Desmos calculator, which you could take full advantage of. So let's say you're not too keen on factoring, or you're not too good at using the quadratic equation or whatever. Just try graphing first and see how far that takes you. But of course, just feel free to ask me any questions. Do these questions if you want that 1 grade dropped. Do the rest of them if you want 3 grades dropped. Besides that, that's all I have. You could always reach out to me, or Mr. Martinez knows a lot about math. Feel free to ask him.